friends, this video is going to be on analyzing functions. And we've done bits of analyzing functions, now we're going to put it all together. So this is our picture. And the first question is the graph a function? And yes, the graph is a function. And the way that we know the graph is a function is because if we were to take a vertical line and we were to move that vertical line across the graph, that vertical line would only intersect the graph at one location every time I move the graph. There's no way I can move this vertical line through the graph and not have it hit more than once. So the answer to that question is yes, it is a function. And that's going to be a pull down menu for you, so you will be just fine on that. Then the next question is it even, odd, or neither? And if we were to take and we were to fold the graph along the y-axis, then this curve of the graph would land on this curve of the graph. The other way to think about that would be if you pick any random point. For instance, if you pick this point right here, which I'm going to say is the point, -1.5, -4. If I were to pick this point right here, it is +1.5, but still -4. If I were to pick another point, for instance, this point right here, that's -2, 0, and 2, 0 is also on the graph. If I were to pick, let's say I were to pick this point right here, that looks like it's approximately -0.5, -1. Then if I look at +0.5, I should still get -1. And if I look at +0.5, I still get -1. So yes, this is a function because for the x values and their opposites, the y values are the same. For the x value and its opposite, the y value is the same. For every x value and its y opposite, the y value is the same. So I'm going to say that this is even. Okay. All right. Then I want the domain. For domain, I always like to remember that if there are no arrowheads shown, the arrowheads are implied. It's just a formatting issue with the program we use to graph these curves. They were persnickety. So the left-hand side of the graph goes forever left and forever up, and the right-hand side of the graph goes forever right and forever up. But we could put a floor on the graph. We could put a floor on the graph. We could put a floor on the graph right here. That would be the line y equals -4. So as far as domain is concerned, domain is the smallest value of x to the largest value of x. So the domain is -infinity to infinity. The range, on the other hand, is the smallest value of y to the highest value of y. So the smallest value of y is -4, but the largest value of y is also infinity. And -4 is actually on the graph because this point right here is the point 0.5. No, 1.5, wasn't it? 1.5, 4. And this point right here was -1.5, 4. So the smallest values were -4. I don't know where I lost my negative signs. There we go. All right. And then I did tell you in the problem that those points are on the graph because it wasn't obvious. I was afraid that people would get irritated at that. Okay, so let's do, there is no place where this line goes flat, so constant doesn't exist. But decreasing, it is decreasing. Okay, so here's the thing with increasing and decreasing. Increasing and decreasing, we only want the x values. So we are only going to look at the x values, and we need to name this point. This is the point 0, 0. So we go to every place where it changes direction. So every place where it changes direction, and we only look at the x values. So we look at the end of the graph, all the places it changes direction, and the other end of the graph. So the things that I've highlighted there in that orange color. All right, decreasing is when it goes down. So decreasing, it is headed down. Oh, I would rather do, yes. It is headed down between negative infinity and negative 1.5. It is also headed down between 0 and 1.5. Increasing is where it is headed up. It is headed up between negative 1.5 and, that's a decimal, 0. And it is headed up from 1.5 to infinity. So that is where it is increasing. And then for zeros, we want to see where it crosses the x-axis. It hits the x-axis here. Oh, my answer key is going to be wrong. I left one out. And here, and here. So those are the three places where it hits the x-axis. So it has 3 zeros. It has 3 zeros, so it has a 0 at negative 2, at 0, and at 2. And I need to go fix my answer key because I left the 0 out. By the way, not that I asked the question yet, but I will. But this is a cubic polynomial. No, it is not. Mrs. Leonard. It is a quartic polynomial. It is a quartic polynomial because it changes directions 3 times. Okay. And actually, the 0 of the 0 is, that is a multiplicity of 2 because it changes direction on the x-axis, so it bounces. We don't need to know the red part yet, though. Okay, I'll keep the red part out of here from here on out. Okay, this one. Is the graph a function? Well, the way we determine if the graph is a function is we drop a vertical line and we run it through the graph and we ask ourselves, well, can I put this line on here in such a way that it'll impact it more than once? And yes, it impacts it many, many, many times. So the answer is no, it is not a function. So the answer here is the graph a function? No. And because it's no, it can't be categorized. Categorized. It does have a domain, however. If we list our points, this is the point -3, -5. This is the point, negative 3, 3, not included. And so for our domain is just negative 3. That's the only value that x is on this graph. But it is negative 3. So the only x value is negative 3. The range, however, goes from the lowest to the highest. So the range is including the negative 5, but not including the 3. There is no place on the line where the graph goes horizontal. We do not consider it increasing or decreasing if it's not a function. So we're going to put does not exist on all 3 of those. It does have a 0, however. This point right here is the 0. So the 0 is at negative 3. So that's going to be our answer there. Alrighty, next. Okay. Is it a vertical line? Well, if I take a vertical line, or is it a function? If I take a vertical line and I pull the vertical line through, see right here, there's only one intersection point. Here, there's only one intersection point, one intersection point. It only intersects this curve one and only one time as I push it through. So the answer to the question is the graph a function? The answer is yes, and that should be a pull-down menu. The answer to is it even, odd, or neither? That answer is neither. That answer is neither. If it were even, then if it has the ordered pair, let's say 3, 0, which it does, then it should have the point negative 3, 0, which it does not. If it were odd, then if it has the point 1, negative 4, which it does, then it should have the point negative 1, positive 4, which it does not. Oh, that's not very obvious. I should pick something different. Let's say let's say that point right there. If it has that point right there, what is that point? That is 4, negative 4. If it has 4, negative 4, then it should have the ordered pair negative 4, positive 4. And that's very obvious that it does not. So it's neither. It's not foldable on the y-axis, and you can't rotate it 180 degrees. Okay, the domain. Whoops, we want a different color. If we put arrowheads, oh, there already are arrowheads. I don't have to put them. This arrowhead is going forever to the left and forever up. This arrowhead is going forever to the right and forever down. Okay? So, the domain is the smallest x to the largest x. So the domain is negative infinity to infinity. The range is the smallest y to the largest y. So the range is negative infinity to infinity. There is nowhere on the graph where it's laying flat, so that does not exist. To do increasing and decreasing, I want to look at x values only. I want to look at the farthest left-hand side of the graph. I want to look at this change of direction. I want to look at this change in direction. And I want to look at the farthest right portion of the graph. And I am going to say that it is headed downhill between the x values of negative infinity and 1. So it is decreasing between negative infinity and 1. It is also headed downhill between the x value of 3 and the x value of infinity. It is headed uphill between the x values of 1 and 3. And these are always parentheses. Increasing and decreasing are always parentheses because it doesn't stop. It continues moving, okay? There are zeros. There are zeros. There are zeros. It crosses the x-axis here. And it crosses the x-axis here. So there are zeros. There are zeros at 0 and 3. And not that it's asked yet, but this is a cubic polynomial. Its parent function is x to the power of 3. Okay? Alrighty. Last one. Yes, here we go. Is it a function? If I were to take a vertical line, and I were to take that vertical line, and I were to move it through the graph, the orange line, my vertical line, and the black line, the black graph, will only have one intersection each and every time. So is it a function? Yes, it is a function. Is it an even, odd, or neither? It is neither. And it is neither because if you fold it on the y-axis, it will not fold on top of itself. Also, if you wanted to check if it was even, that's a fold on the y-axis. It also means that if you have the ordered pair negative 8, 2, you should have the ordered pair 8, 2, and you would not. So it's not even. If it were odd, if you had the ordered pair negative 8, 2, you should have the other ordered pair 8, negative 2, and you do not. So it's not odd. So it has to be neither. Okay, I'm going to label some points. This is the point, negative 8, 2. This is the point, negative 2, negative 4. And this is the point, 6, 4. To do domain, I want the smallest x and the biggest x. So my domain is negative 8 to 6, and both of those are included because those are solid dots. For my range, I want my smallest y and my biggest y. So my range is negative 4 to 4. And those are both brackets. There is no place where this lays flat. It is, so to do increasing, decreasing, and neither, I want to look at the farthest left portion of the graph, where it changes direction, and the farthest right portion of the graph. So, it is headed downhill between the x values of negative 8 and negative 2. And it is headed uphill between the x values of negative 2 and 6. It crosses the axis, the x-axis at negative 6 and 2. So its zeros are negative 6 and 2. All right, my friends, that is the way I would go about doing those. Have a great day. If you have any questions, email me or ask me in class.